Hi, good afternoon. My name is Matt, I'm CEO of QuantWare. We are a spin-out of QTech, and for those of you that don't know us, we are the largest commercial supplier of quantum hardware in the world. And for those of you that do know us, you probably know us as a company that ships, say, 64-qubit chips to customers in 22 countries. That is about to change, because this industry has been stuck on scaling QPUs. And the reason that we've been stuck is that these QPUs are two-dimensional. And because they are two-dimensional, we need to use on the order of 90% of these chips to route out the signal lines. We package these in very large printed circuit boards, and these then go into cryostats in a forest of cables and other components. And then these cryostats, because we're limited in small size, we then network them. And networking leads to an exponential increase in total cost of ownership because these network connections are lossy and low bandwidth. And so, maybe to recap that a little bit, the industry today is stuck on the order of 100 qubits. This is due to fan-out, bulky non-integrated components, and exponentially decreasing yield. You can see a picture there of a 120-qubit QPU, and you can see how large that printed circuit board is. And so this forces us to resort to networking, which is exponentially higher total cost of ownership. And so, from the start of QuantWare, we have worked on something that we call VIO. And VIO is a scaling technology that resolves these bottlenecks. Instead of taking the signal to the edges, we bring in signal to the top, which means that we don't need to use that 90% of space to route the signal lines in, and we can use that to put in much more qubits in the same density. We then stack a vertical stack of chips on top of these horizontal chips, and these cubes of silicon go into modules that attach together. In those vertical chips, we can integrate the upstack components, so there's no more bulky components. And between these chiplets, we have ultra-high fidelity chip-to-chip connections, and so there's no more lossy networking. So, to recap, VIO resolves the QPU scaling bottlenecks, fully three-dimensional routing, no more fan-out, fully integrated components, fully modular, extremely high heat transfer because of the way we integrate those chips, and rather than lossy networking, ultra-high fidelity chip-to-chip connections. And because we use ultra-high fidelity chip-to-chip connections and not lossy networking, VIO-powered QPUs provide exponentially more compute than competing approaches. This is data from a study that will publish somewhere early next year, made together with our partner Darkcore. And what this shows is runtime versus networkness. And what this shows is that as we increase the networkness of a given system for a logical circuit, say in this case 60,000 logical CNOTs, the amount of qubit time that we need to execute that circuit increases exponentially. Note the log scale. So all the way on the left, there's a VIO monolithic system. All the way on the right is a system of, in this case, 625 nodes, network system, doing the exact same algorithm, and it takes about 100 million times more qubit seconds to do this thing. And so this is massive, because not only do we provide exponentially more compute, more importantly in this work, we show that this increases with system size. So as we get to larger and larger system sizes, making QPUs larger will get more important. And so we're very proud to announce today the first step towards scaling to million qubit systems, and that the industry is now entering the kilo-qubit era. We're announcing VIO-40K, which is a 40,000 line version of our scaling architecture. 40,000 signal lines. The chiplets that go into these systems have these ultra-high fidelity chip-to-chip connections. It has fully integrated components, and perhaps most importantly, this scales up any superconducting qubit design, whether you're using transmons, fluxoniums or cat qubits, everything. And because we have this very high density, we don't have this routing, all of this fits into a module, say on the order of 10,000 qubits, of 15 by 15 centimeters. If you want to check it out, we have a booth over there that is to actual size. So this is extremely small. We are offering this to the entire industry. So we're not just scaling our own QPUs. We offer QuantWare design processors for system integrators, foundry services for fabless designers, enabling qubit designers to make much, much larger QPUs than they can today. And we offer VIO as packaging services for quantum chiplet makers. With VIO, we enable our customers to produce the fastest scaling roadmaps. You know, you're not going to build a 10,000 qubit system overnight, and so we enable our customers to scale into this roadmap to, as fast as possible, be on the kilo-qubit scale. And so to give an example, in the case of QuantWare designed processors, Tenor, based on VIO-400, is shipping next year. That allows our customers to do logical operations. VIO-1K, shipping in 27, with 1,000 signal lines, 250 qubits. Baritone allows our customers to do logical circuits, and then going one abstraction level higher, Base, our QPU based on VIO-40K, shipping in 28, allows our customers to do quantum algorithms. Systems built with VIO-40K with 10,000 qubits and QPUs made with VIO-40K will drive the world's most powerful quantum computers. So again, taking the example of Base, this is a system of 10,000 qubits in a single cryostat. A system built with such a QPU delivers 2,700 times more compute per dollar invested than a network-based approach. And perhaps most importantly, we enable our customers to do this with a mature and complete system stack. We are partnering with the best in industry players to deliver all of these components that you need to build these systems. And as you can see from the render, because it's 15 by 15 centimeters, a lot of this is available today already. And so, as part of this stack, to make these very powerful quantum computers, we need very high throughput, low latency connection to control the control hardware of these systems. And so again, we partner with the best in the industry. And so for this, we're proud to announce today that we're partnering with Nvidia. So I'm incredibly excited to invite Shane to the stage from Nvidia to talk about NVQLink and VIO-40K.
Thank you, Matt. Can I just say we're thrilled to be partnering with QuantWare on this bold scale-up with VIO-40K to hyperscaled quantum computing. At Nvidia, we know that at this kind of scale, quantum computers are going to have to be paired with the world's most powerful classical systems. And so that's why we've built NVQLink, an open platform architecture that can handle quantum systems at this scale for workloads of QEC and QPU calibration at hyperscale.
Thank you. The kilo-qubit era will require not academic one-off devices, but industrial scale production. And so as part of this announcement, we're announcing Kilo Fab, which is the fab we're building, which will be online in 2026 next year. And it is the largest dedicated quantum open architecture fab in the world. Kilo Fab will produce kilo-qubit arrays and VIO-40K. It will 20x our production capacity by next year. We're also announcing VIO-HDK, or Hardware Development Kit. This is made to help our customers integrate VIO in their scaling roadmaps starting today. This enables you to either integrate systems with VIO today, or get your qubit design into VIO, or integrate your qubit chiplets into VIO. This is shipping. It's not on the slide anymore, but it's shipping right now. And then finally, VIO-40K is available for order today to reserve your spot in our production schedule. It's available either as a standalone array or with our go-to-market partners to provide integrated solutions, including control hardware and NVQLink. Together with our ecosystem partners, we are incredibly excited to kick off the kilo-qubit era and to see the impact that VIO will make in this industry. Thank you very much.